we are going to review solving systems. One method to solve a system is substitution. So we have 2x plus 3y equals 4, and we already know what x equals. Anytime you have one equation that's solved for one variable, doesn't matter which one it is, take it and plug it in. So substitute. Instead of an x, I'm going to plug in 2y minus 5. And then finish the rest of that top equation. So I plugged 2y minus 5 in for x. Now I only have one variable. Let's finish solving, distribute. Combine like terms. Oops, step ahead. Add the 10. And you can easily solve for one variable. Once you know one variable, you can plug it into either equation. The second equation looks easier to me, so I'm going to plug it into x equals 2y minus 5, but I'm going to plug in 2. That's going to be in the way. So x is going to equal 2 times 2 minus 5. X equals 4 minus 5. X equals negative 1. We are solving systems. Notice the question was 2 lines. 2 lines cross at a point. Make sure you write your final answer as a point alphabetically, x comma y. We are solving for the point of intersection. So hopefully that looked familiar. That was a review of substitution. Next we have a review of elimination. So this time both variables are on the left, or on the same side is what matters. Neither equation is solved for one variable. And if I tried to, I'm going to get fractions. No one likes fractions, let's be real. So we're going to use elimination instead. If I can get one of my variables to be the same coefficient, but one be positive and one be negative, then I'm going to be able to do elimination. So you have choices here. Because personal choice, because the y's are opposite symbols, I'm going to try to eliminate the y's. So I'm allowed to multiply whole equations. So keep an eye on what I'm doing if you're not quite sure why. If I multiply this whole equation by 5, the whole thing, so 10x minus 15y equals 5, what can I multiply the second equation by so that the y's are going to be the same number but opposite symbols? Hopefully you see that I can multiply it by 3. Distribute the 3 to everything. 9x, it becomes plus 15y, that's what I wanted, equals 33. So you choose the numbers that you're going to multiply by. Sometimes it's one equation, sometimes it's both equations, so that the variables have the same coefficient with opposite symbols, one with the plus, one with the minus. Then you take your equations and you add them together. Sometimes this is called the addition method, because when I add them together, I get 19x, but look, the y's cross out, and it just equals 38. That's super simple to solve for x. Divide by 19, and x equals 2. You're halfway there. Remember, you're solving a system of equations. The original question had x's and y's in it. You are looking for the point of intersection. So you need to plug that answer into either of the first 2 equations. The first one looks a little better to me, right? There's nothing as big as 11 in it, so might as well use the first one. We know x, so plug it in. And solve for the other variable. I got y equals 1. Answer is written as a point to get full credit. Point of intersection, x comma y. Now, sometimes when you're solving a system of equation, there might not be a solution, because if 2 lines don't cross, right, then there is no point of intersection. Or there might be infinite solutions. So if it was the equation of the same line just written differently, then it would be infinite solutions. The no solution, when you're doing your problem, it might come out to say, like, I don't know, 7 equals 0. We all know 7 does not equal 0, so that's when you would say, oh, this has no solution. It's never going to cross. The infinite solutions, if you're doing your math, it might come out to say, just for example, 5 equals 5, with no variables left, right? Everything goes away and you're just left with 5 equals 5. Well, we all know that is true, and that's when you would say it has infinite solutions. So hopefully this looks familiar. It should have just been a refresher, and I hope you guys are doing well.